Hi and welcome. I'm trying to learn particle physics. Today the three generations of particles, and after we've done that we're going to do ECU tendon training. The ECU tendon is here. And if you participate in the ECU tendon training, that's better. The honest again, this is part 3, 4 of it. If lepton universality is broken, so we're saying three leptons, electron, muon and tau, all in the same amount. There's always one electron, one muon and one tau. But now we did experiments and where we found a 25% decreased probability to get a muon after decaying something. If lepton universality is broken, the most popular explanation is that an unknown particle appears fleetingly during the meson decay and interacts with the various pieces of particle chapter, pushing their ratios away from what would be predicted. The explanation is what we use is there is some other type of particle which comes while this meson, which is used into decay, and we expect now 3 leptons, and that meson somehow interacts with it and makes it less likely that muons appear. This particle would appear and disappear in a flash too quickly to be directly detected itself. One possibility is that it might be a leptoquark, a hypothetical particle whose properties allow it to bridge the gap between quarks and leptons, making it possible for one to turn into the other. Let's do it again. One possibility is that it might be a leptoquark, which very shortly is there and pushes the muons away. But we don't know if it is true. And this leptoquark is an idea, just an idea. Maybe it is there. And then the idea is that it is a bridge between the quarks and the leptons. So it makes so that it is possible for it that it turns from one into the other. That's what it means. Now there are these 6 quarks and 6 leptons in all fermions. And we have no idea of a leptoquark. If the leptoquark were also to fix things such that certain leptons change to quarks more readily than others, it would explain the unequal proportions observed at LHCP. Let's do it again. If a leptoquark were also to fix things such that certain leptons change to quarks more readily than others, it would explain the unequal proportions observed at LHCP. So another experiment, I don't know. There were things which didn't apply with the universality rule of 3. But there were one muon, one tau and one electron. A search for leptoquarks in the 2000s at an accelerator called HERA in Germany found Schlich. Is that the name? Schlich. But this doesn't rule them out entirely. Because HERA operated only at a certain energy. Is that a printing error? If it founds Zilch, then that's a good thing. Whatever was happened there didn't rule out the idea of a leptoquark, which could, if it exists, be a bridge between the 6 quarks and the 6 leptons, push them around and change the probability of them to appear. But this doesn't rule out that these leptoquarks exist because HERA operated only at a certain energy. One speculative possibility that this might open up is that electrons, and with them muons and tauons, aren't fundamental particles in their own rights, but composites. They are not fundamental particles. Okay, we have to find one out in one place where fundamental particles are. They are the fermions, the particles that make up matter. These consists of 6 quarks arranged in pairs to make 3 generations identical in orbit mass, and 6 leptons, such as electrons and neutrinos, arranged similarly. No, I think we said something about fundamental particles, but it wasn't here. One speculative possibility that this might open up is that electrons and lithium muons and tauons aren't fundamental particles in their own rights, but composites. The electrons whizzing through our electrical wires are far more complex beasts than we have assumed, and the chunks they are made from might conceivably combine in other ways, perhaps making other, heavier variants, for example. Other heavier elements, for example. Okay, the electrons used in electricity are more complex than we thought. The electrons whizzing through our electrical wires are far more complex beasts than we have assumed, and the chunks they are made from might conceivably combine in other ways. Perhaps making other, heavier variants, for example. Whatever. Under this scenario, the glib answer to why are there free charged leptons is simply there aren't. That is just all we have seen so far. Because there are more, or because we're not able to see them without being in a chunk or whatever. The answer to why are there free charged leptons? There aren't. It's just all we have seen so far. Whatever. That was a part of the free generations. So basically that was a problem that there is in decaying of mesons does not happen this free, but the muons don't happen as often as they should. And now we are fiddling around why that happens. And there is the idea of a leptoquark, and however that happens now. So other particles who have an influence on the particles, so that it does not happen that the muon exists all the time. And that the electrons at least are more complex. Electrons, muons, and taus. Okay, we will continue at the next part with particle physics. Maybe that gives us more ideas for what's happening. But for now we are done with the particle physics. You can go directly to the next part of particle physics. We will do now the ECU Tendon training. If you participate in the ECU Tendon training, that's the idea. Go to single sides, arms in. Arms next to us, hands onto fists, and we bring the fists down. And here. The next exercise, the counterfeit might check. Fists, and bring these fists up. And down. We having 3 rules. The first rule is that we are stopping immediately as soon as there's pain. The second rule is that we're going only as fast as we can go with a little bit of effort. And the third rule is that we're not overdoing it. We just want to strengthen, not to exhaust. If you feel like taking a break, do it. I'm going to use now a tennis racket. A tennis racket is light. It just has around 300 grams. So whatever you use, do it in accordance of our 3 rules. It has a long lever. The manico. Elbow in, take the lower arm, and go slowly over to one side. And over to the other. And that was the last time. Now over to the lower part. And it was for the last time. Now take the racket from the top, or whatever, and lift it up. Bring it once over. Back in. And down, half step over. Another hand. Up. Over. Back in. And down. Another palm facing upwards. Again, up. Over. In. Down. And another time. Up. Over. In. And down. And now the same with the other arm. First, manico, small arm on one side. The other one. That was the last time. And the middle, and now with a long arm out. Now the house door, from top, up, over, in, and down at the same time. And now the garbage truck scraper arm, the part facing upwards, and the same. And again. And when you use no sock back, you can also use a t-shirt or a towel. Press with good force onto it, and bring the wrist up and down. Again up and down. And now switch with your hand. Press and bring the wrist upwards and down. And now last exercise, just press with moderate good force on it. And switch over and press again. And that was the ECU 10 training. Thank you very much, and until next time.